Hi, welcome to the Animating Expressive Faces workshop. My name is Santiago and I have been working with Spark for the last 3.5 years. My name is Santiago Anglés. I'm from Uruguay, South America, also known as Anglés. I'm a creative technologist. I am a programmer, but also study animation and design. So I combine all the three areas. Um, my expertise is animation by code and also doing procedural stuff. I work on my career mostly on multimedia, advertising, and also video games, doing some engines and frameworks. And I have been working always with new tech. Like when Flash started, I dove in and started working with that. Then Unity and now Spark. So I always try to find new ways to be creative and integrate technology on my projects. For the last 10 years, I have been working with the Electric Factory. I'm creative technologist there. I'm the director of the AR and VR division. And in particular, I'm the director of the Spark AR team. We have a dedicated team working with the Spark effects. And in the last couple of years, we have done several projects for clients. Um, let's see some reels about it. Uh, we have worked on brands mostly, so it's kind of different working with brands. Brands need to reach the users, but we need to help them figure out how. So we try to do enjoyable projects for them, but also try to help the brand pass through the effect itself. So it's quite different working with brands because we need to do the project, but also teach them how to follow up the the platform and how to change the language with the users. We have done almost 200, more than 200 projects, and we have grown up with Spark. Spark had a lot of features that were removed, and they add new stuff. So it's a living platform. It gets new stuff and it gets it try to polish the platform. And for us it's rewarding because we are growing with the technology and we can invent stuff that is at the same pace as Spark. We have done some third-party projects for Messenger team, and we have also done some research for them. And mostly it's that we work with brands. It's quite different that working for yourself, but it's enjoyable. At the end, it's enjoyable. We have a dedicated team, as I was saying, and we have animators, programmers, we have 3D developers, and also an animation studio inside the company, so we can do a lot of stuff. That's a signal that the technology is getting more common and people are getting jobs on that area. In fact, the last few um, people that joined the team were from Creator Day, so we hope you have that future also. So maybe we can go to what we are doing now. One example of what we are going to create today. a 3D face with expressions. We will try to get as much expression as we can from the face. Also, we can detect stuff that is not present, but we can calculate them and add animations and details to the face. In this example, we have ears that goes to the back of the face when you raise your eyebrows, and also if you move the mouth from side to side, the mouth also reach that part of your face. This is an example of what we are doing. We will try to get to the size, the one on the left or the right. That's what you are going to make. We have some teeth added to the middle one, but that's something you can add later on. This effect were done when Facebook Mexico reached us to try to research how a brand can work on effects, and we find a lot of them, but two in particular were faces, and we thought that the brand will emerge from the effect itself. So we tried to use the gestures that came on Spark, but they weren't as detailed or responsive as we like. We will say that in a couple of minutes. But the idea was how we can detect more wider range of effects. Later on, we work on several effects and add them and construct on top of what we learned before. So here we have, for example, a face that has a mustache that rotates when the mouth moves between sides of the face. And in the right side we have a puffer fish that gets like seams on the like a sad face, but also the eyelids change position to show that is mad, that is angry. That's the something also that can be done. We detect a gesture and then modify the structure of the face accordingly. And finally, you don't need to stick to get an expression and show it on the face. In this case, we have the expression as detections, and then we can trigger an animation. In the left side, we have a sad face. When we detect you are sad, we apply the animation. In the middle one, we have a pucker effect. When you throw a kiss, let's say, some hearts come out of your mouth. And in the right side, when you are laughing, you get the animation of the laugh. In Spark we have some of this expression, but they have a threshold that is not as good as we needed in these ones. So we had to figure out how to detect them and how to create them. So let's start with the concept. We will start from an idea what the face might look like, and then we do a playground version. We call that the playground because we try stuff, we try new things, we try how that can be done and how it will work on a 3D space. When we start from a design perspective, then when we switch to the 3D version, some things might change, some things might not work. So we play around a little bit, and then we go to the refinement version. Then we add more details, more stuff, materials, details on the materials, and that creates a newer version. That's the process we use to work on every Spark AR effect. So the idea here will be similar. So let's begin with the 3D model creation. We use Blender for that end, and here we have an example. we have a 3D face. Let's work around the project. We have a reference face here for a drawing I did. It's just a concept. It's not detailed enough, but just a rough idea of what we want to achieve. Then we went and modeled the face. For the face, we try to get everything in place. So when we import that on Spark, all the things will match on size and position. When we did this project, we didn't have the plugin for Spark AR. I recommend that. It will check sizes and figure out the scale for everything. It's a more simple way to work with the Spark. And also here we try to figure out what we are going to do. So for example, in the nose, when we want to rotate the nose, we have the origin on the top, so it's easier for us to do it by code. Also in the edge leads, we have done that, so when we rotate on the x-axis, we have also that working. And we have done something similar for the eyebrows. The eyebrows are on the origin is on the eyes also, so when we rotate them, they will rotate around the eyes and not in the same place they are. So this is some decisions we do on the model itself, and then we figure out how the rotations and all that will work. And when they are important in Spark, it's simpler for us to work on them. And for the mouse, the most important part of the project, we created several blend shapes. A blend shape is a model that has the same amount of vertex and is simply the same model duplicated and change it. Change on shape, change on size, change of distribution, but the same amount of vertex. In this example, we have each one as a same separate object, but then we mix all them together as a key blend shape, and we end up with a mouse with some blend shapes here. So we can change one value, we can change other value keys, we can change the sadness, we can change the smile, and we can change the span. The better to have a few changes on the mouth, because if we go all the way around with a lot of expressions, it's difficult to sum them up. What I mean is that if you change all the expression at the same time, the mouth will break. So this is something that is doing all the stuff at the same time. So we try to have a few mouths, but with simpler expressions, and combine them as much as we can. So for example, we can smile, and also we can open the mouth. So there we have two expressions at the same time. Some of them are the opposite. So if we put, let's say, if we apply sad and smile at the same time, they quite cancel each other. So that's something that we need to know beforehand, so we can tweak the values for that example. So that's the idea, having a 3D face already done and importing it on Spark and starting creating the effect. For this part, we already have a face for you on the assets, so don't get nervous. That is already done. If you would like to create your own face, you are welcome, but there's already a face on the project. Let's start with the park. For this effect, we will provide you with a base project to work on, but I want to show you some stuff from the 3D model when you import them. So let's start by creating a blank project. And on the resource folder, you should have an asset folder, FBX model folder, and a few files there. We will only use eye, face, and mouth files. To import them to Spark, we simply drag and drop the file onto the asset panel. We do the same for the eye, and we do the same for the mouth. To track the user face, we need to add a face tracker. The face tracker will have the position, rotation, and scale of the user face. So if we put anything inside that face tracker, it will move according to the face. So let's move the face. Let's put on inside the face tracker, and you see that that moves and rotates as the user face. The same rotation, scale, and everything. For the eye, if we drag and drop it, it will have the correct position as we get on the 3D program. But we only have one eye. That's because for some projects it's better to have one only instance of meshes that have the same structure. So the right eye and the left eye have the same proportion, the same meshes, the same sizes. So why bothering having two models inside the same FBX file? If we have one, we can duplicate it and use it again. In this case, we will do that. We will add to the face tracker another eye, and instead of moving it by hand, we simply go inside the model and we choose each of the meshes and put the opposite position for the X value. So in this case, we negate that value, we add a minus on the front, so we have that move to the other side. We do the same for the eye, and we do the same for the eyebrow. Although everything is in place, the eyebrow is rotated, so it's in the same position as the other one. So simply give a rotation on the y-axis of 180 degrees. And we have another eye completely similar to the left one, but we have more room for textures. Finally, let's add the mouth. The mouth, when you add to the project, you can see it's kind of strange. That's because all the blend shapes are in full value. So to fix that, we select the mouth mesh and we set all the values to 0. There we have the mouth correctly placed, and we can play around with the values to see if they behave as we intended. Now let's start working with the base project. For that, we need to go to project folders and select the base project package. This base project already has all the 3D models in place, and also a few other things like the JavaScript file with all the patch to script connections already done. Also, we have a exponential smoothing vector 3 patch that will help us in a little bit. Let's start by animating the eyes. For that matter, we need to create a patch for the face tracker. The face tracker is the source all the information about the face. So we need to create a patch by dragging and dropping that on the face on the patch editor, or we could select the face tracker and go into the properties panel and click on create and create a producer patch. It's the same both ways. To rotate to detect the rotation of the eye, we need to take in account how the eyes are already rotated. So let's start by adding a edge ball patch. The edge ball has all the information about the eyeball, like where the iris is placed, the center of the eyeball, and also the rotation. We will use the edge ball rotation. To rotate a model, simply select that and select the arrow that is on the rotation values, and this will create a patch that you can put info into. Notate that our model is has already a rotation on the x-axis, so that is something that we need to correct. For that, let's add a patch and connect the right eyeball with the model. Remember, this is the right eye. The name is just an internal model, but it's not working as we expected because we need to take in account that minus 90 degrees value. So simply add a value. We add patch with vector 3 and we put the 90 degrees, and when we connect the original eyeball rotation to that, it will add 90 to the x-axis, nothing to the y, nothing to the z, and finally we connect, and that's working as we expected. We can see that it's working. To try it out more easily, we use the webcam, and if we look at the size, we can see it's already working. So let's do the same for the other eye. We select, we add a rotation, add a vector 3 because we need to have 3 values on the rotation component, and then we connect the rotation. Let's see again if it's working. So we have already working. For the eyelid, we will do something more specific. Let's start by the right eyelid. We already have a rotation, so note that. And on the face tracker, we can also get an edge lid patch. The edge lid patch gives us a lot of information about the edge lid, where the left eye center, left inside corner is placed, on all that. We will only use the openness, the right openness and left openness. These values go from 0 to 1 when the user close the eyes lid. So when we close our eyes, we have 0 values, and when we open wide, we have 1 value. In this case, we will not use the value as it comes from the patch. We need to change that. We will use toRange value. toRange get a value from 0 to 1 is what is coming from the, let's use the other one, I get the incorrect one. The toRange get a value from 0 to 1 and gets the, when it's 0 it puts the value from this one, and when it's 1 it puts the value for this one. So and all the in-betweens are calculated by the patch itself. So I put 40 degrees when it's 0 and minus 50 when it's 1. So let's try that out. But we will have a strange behavior because in this part we only get 1 value, and in this part we need 3 values. Spark converts when you have 1 value, it sets the same value for the 3 components. So let's use a pack patch. A pack patch allows us to give 1 value for each axis. So let's put it on the x-axis. So there we have. We need to play around with that because we need to figure out the best value for what we need. So in this case, I tend to close my eyes, put the mouse on the pause, and close my eyes and pause the video. Now I can put some values and test how much I want it to be close. Then do the same for the open. Let's put play, open the eyes as much as you can and pause, and then do the same. Let's put 75 and let's try. I think it's working, so great. And do the same for the other one. We can copy and paste. We can copy and paste. And we have a blinking model, and the eyes are working correctly. Now we are going to work on the mouth, but on that end we need to talk about how to detect better values for the mouth. If we get the patch for mouth open, we will see that we will have a open state that will trigger true or false if our mouth is open. There, on there. Let's hide the model for a bit to see that value. But also we have an openness value. But in this case, if you want to detect a precise movement, the openness value has some threshold that doesn't show. I am talking right now, but it doesn't change at all until I wide open the mouth, and then that will trigger the value. That is normal for some effects, but if we want to have the mouse to be very responsive, we need to change how we detect that. For that, we have a project to explain that. In this case, we have some dots on, this is just an example to explain. We have some dots on the face. These dots are values that are from Spark. In this case, the red dots are the left and right mouth. We have the blue dots that are the bottom and top values. Then we have the arrows that have the left and right top position. And also we have the eyes that have the equal center and right equal center. So that's values are all from Spark. But in this case, we have a face that has that points that are information for us, and we have a coordinate system that has a axis on 0 on the center and on 0 here. So for us, this is information. We can play and do some math and calculate things from them. In this case, we can calculate the distance between the red dots, the left and right from the mouth, and we can detect how wide is the mouth, or also how slim or in a kiss position is. So that value is important for us, is the distance between the 2 points. Also, if we know how the origin is on the center, if we move in a lateral position, we can calculate how the mouth is moved from the center of the face. So that is also important for us. If we get the midpoint of the 2 red dots, is moved to the right or to the left. And that is also using taking in account that we have a center value on 0 here. That seems complicated, but it's just simple math applied to this concept. For the openness, we do the same, but just on the top and the bottom part of the mouth. And we have a value that is always responsive and always show the correct value. We can do the same for the eyebrows, but we can use the ones in Spark just to let you know that you can play around with that too. These values we will use from code, and for that we already place a code on the base project. It has a value for each information we need. In this case, mouth center, we calculate the position of the mouth on the horizontal axis based on the midpoint of the mouth. And we have for mouth center, mouth wide, mouth kiss, mouth open. Also for a smile, we use upper lip curvature. That is a feature that it's not present on patches. So that's why mostly we use code, and also it's easy to pass that from project to project. Also for SAD, we use the lower lip curvature. This is already explained inside the code. If you want to dig deeper, just take the file and read a little bit. We have some values that we use to figure it out and to fix some ranges, but that's mostly what we do. So let's back to our project. Let's turn on the face tracker again, and let's play with the mouth and the blend shapes. We will not use the face tracker, we will use the code. You will have these variables from script. These are all the values we have from script. Let's start simple by using the open mouth. For that, let's find the mouth on the project, the mesh, and let's get the blend shape value from the open. It's called weight, is how much the blend shape is changed. If we put 0.5, it's halfway. If we put 1, it's full value there, so it full open. So let's connect that. We search for the most open value, and I always try to put a value first to see how the ranges are for that in particular. We see that we have some imprecisions. We love to have that from script and then fix that on code, on patches, sorry, because that way we can change on each project what the amount is and what and how it behaves on each project. So for that we will use another patch that is from range. We put initial value, and this will be our 0 value, and then we put the final value, the max, and this will be our 1. So we can change from a range of values to 0 to 1. In this case, I will close my mouth. Let's put that way and see how much the value is. In this case, it's around 15. Let's put 0.12, just a start, and then I open the mouth as much as I can, and I see it's 0.7. So when the mouth value is 0.12, it will return 0, and when it's 0.7, it will return 1. So let's connect that, and let's turn on the face again, and we have a mouth there, and it's quite responsive. In this case, I think it's too much, the animation, so we can multiply that a little bit, so we can tune it down, let's say 0.6. So when I do subtle movements, it get my subtle movements. We can try putting the original openness value to see the difference. Let's show if we get the mouse open value and we put the openness here, we should have the same, but when I'm talking it's not getting any movement at all, but when I open wide it's like it jumps. It's difficult for me move the mouth right now, and that's quite what we want to fix. Let's go again and put it as we need. Let's do the same with another expression. Let's go for, let's say, the kiss one. For this one, we need to get the kiss value. The white value and the kiss value are in the opposite side, so we have done a calculation to they will not show the values at the same time. For this we will get, let's sort it out here, let's put a value to get an idea of the values we get, and let's throw a kiss. Let's hide the camera. It's more than one, so we can do the same from range, and we want to not get the value as soon as we start getting values. We want to be like have some a window of when we start doing a kiss. So we will do, let's put 1.2 and 1.2, 0.2, sorry, and 1.2, and let's try. Sorry, let's start, and then we already have a value there that is working. Sometimes if you see, when we throw a keys, it detects that the mouth is open. Let's see the value for mouth open for this one. It increases in value when we throw a keys. So maybe we can delete from one to another, subtract, let's say, not delete, from one into another, so we can fix that difference between them. Let's say we subtract from this, the value of the keys, sorry, we subtract the value from keys, we get, let's say, we subtract on 0.8, and we clamp the value. The clamp patch will get the values on a window from 0 to 1 and discard the others. So I'm already getting this mess up, but let's sort it out. Sorry, working with patches has that playful. So right now what we have done, so to be clear and repeat, we have, when the keys is let's say bigger than the mouth open, it will give more power to the keys and less power to the mouth open, more effort on that blend shape, more importance. So this is the main idea, playing around with values, and we already have a mouth that is moving around and behaving a lot more clear than what we have done before. Let's add a smile. Let's find the mouth, add a smile, and for this we can connect directly and test it out. We can play around with the value to see if we can have something. When I'm smiling my best is 0.8. But in this case I will try to add a value just to get a subtle smile on the user all the time. So we have saw this quite difficult because we need to compensate on the smile. So that value you can play around later on. Let's use mouth wide and mouth center to finish the project, the mouth part. And in this case, mouth wide is simply getting the value and applying to the expand here. Put it. I think it's too much of the size of the expanded mouse, of the wide mouse, is too much. So we turn it down by multiplying it for, let's say, 0.5. So we will have the half expansion as much, maybe. So there we have. And the last one is another gesture that I want to play around. In this case, we will try to move the mouse from side to side. When the user does this movement, we will love to have that captured for the user. Some filters that we did earlier, we saw that that's a gesture the user relates immediately. Then when they can do that gesture, is, oh, this is nice. they can kind of enjoy immediately that gesture. For that, we will not try to play with the mouse. We will try to rotate the mouse. Instead of moving the mouth, my mouth is not moving laterally. My mouth is rotating around my face. So that's the idea, and we can do that quite easy because our mouth has an origin also on the center of the face. So if we pause by a little bit, we rotate on the C axis, we can see how the rotation could help us on that end. If we move, it's quite not natural. You can do that. It's a matter of aesthetics, but for us, we will try to get it rotated. Let's start putting a value and see the range of value we get there. Let's put my mouth on the side and on the other side. So we can simply multiply that for a value of rotation, and let's unclutter this a little bit. Let's put it here, and we need to rotate the mouth container, so let's do a rotation there. We need to pack the value because we have 3 values here, a vector 3, and here we have a single value, vector 1. So let's connect that together, and we will working on the Z axis, and let's put a multiplication, multiply, and this is just playing around with values. Let's put 35, and we created in code a value that is negative when it goes to the left and positive when it goes to the right. So let's put we already have it working, but it kind of jumps around. So for that, I have created a exponential smoothing patch that inside it has 3 exponential smoothings. Let's find, and it combines as a single value. So we can put it inside. It has a value of 70. So this way we have a more smooth movement and not quite crazy movement. So here we have our mouth, and we can also apply that to our nose. That's the idea. We don't have to match each expression to the same real expression. We can rotate the mouth and also the nose on a single expression. So let's rotate the mouth. In this case, we need to do a pack also. And we already have a minus 90 degrees on x-axis, so let's put that, and let's have that, and here we have. Maybe it's too much for the nose, so let's multiply it by a value, let's say 0.5, and now it's more natural. So here we have. Let's do the eyebrow, and we think we are getting ready. Now we are in the last part of the tutorial. We are going to move the eyebrows, but in this case we are going to do that on patch, not on code, so you can see how it could be done on patch also. In this case, we need to get an eyebrow patch. It gets inside, outside value, and the top. We will use the top value. And also we need the eyebrow patch also, because in this case we have the eyebrow center. So let's start by working on the left eyebrow. So we subtract from the top to the center of the eye. So let's subtract from left top to left center, and we are working on vector 3 values. We can use the whole values, but we only need the y-axis. So in this case we can unpack and use only the y, or we can do better, swizzle. The swizzle will get values from a vector 1, 2, 3, or 4, and you can rearrange and change the components of the output of the reorder value. In this case we put y, and we only get a y value here. So, and this is a range also. When we lower our eyebrows, it gets to smaller values, and when we raise our eyebrow, we get also bigger values. But in this case, let's put a value. They are very, very small numbers. So when I lower my eyebrows, I get 0.022, and when I rise, I get 0.035, let's say. So we get also from range, and we can do that 0.022, and when I raise my eyebrow, 0.037, let's say. So we kind of normalize the values, so to 0 to 1, and let's simply move the eyebrow. The eyebrow is here. We can add the position, but in this case the eyebrow has a lot of values, and here's another trick I like to show you. When you have a lot of value here, changing this position is quite difficult because I have to sum all that, but I can add a empty object. Let's put eyebrow holder, and this is placed on 0, 0, 0. So we can move that holder and move the eyebrow inside that holder. So it will move when I move the holder. This case is asking me to confirm that I will break the 3D model, but trust me, it's nothing to worry about. So I confirm that. Now I have a value 0 here, and the edge row is inside, so we can play with the y-axis, and it was a much bigger value than I thought, so we can play around with that value. So let's add the movement. So position, we need that, and we back also only to change the y-axis. And in this case we have values from 0 to 1. It will be a huge number for this, so let's put just to see, but we need to multiply for a simple value. I always love to have values from 0 to 1 and then multiplying the value, because in that end we can change the value without touching the rest of the components. So here we have one working. We can do that more exaggerated. So here we have, we need to copy all this for the other one. We have done the same thing we did in code, but with batches. It's quite easy. It's just let's fix that by center, and we have right up here, and we have all this moved. We need to do the same on the other eye. Create a empty object. Let's put the same name, H-ball holder. Confirm, nothing to worry about, and then we can move that. It's a simple trick. When something is difficult to move, let's put a holder and move the holder, and now we have like an expressive face. I don't have the ability to move the eyebrows differently, separate movements for each one, but it will show as the user has that ability. My face is quite not as able to do that. And also we can do, if we get the expression of sadness, or maybe the user is mad, we can play around with rotating the edge lids to do that gesture, or no, or also the edge brows. We can, when the user expression is they raise the edge brow past certain level, maybe we can rotate them also. Let's have a final talk. The last step is to upload the filter into the Spark AR platform. For that, we have a button here to publish the effect, and also on the bottom right. And when we press that, we have the ability to upload directly to the platform. We can record the video inside here, which is the right camera, and we start recording. Hi, that's a filter I made in the workshop today. The video is prepared. We can save it, and then we click upload. After the file is uploaded, we will get a page hub when we can put a name here, Spark Creators Days, I can choose which platform I want to put it on, how the filter should behave, my personal Facebook, and then we can have some categories. We can add, let's say, funny. I have it in Spanish, but let's say selfies. And also I can have a keyword there, and also select the thumbnail for the filter, and finally the icon, and I can upload my own. I could add my friend or some partner that did that filter with me, and then it's just click send. So that's it. We'll have a project working. Feel free to use the base project. Feel free to start from scratch, and I will provide a working project so you can work on the models if you like, or maybe create your own faces around this technique. Feel free to use it and have fun.